Okay, so for this problem, I'm going to do the integral of sine to the 5th x times cosine squared x. And on a lot of problems, if you have something like sine times cosine, and they're raised to some power, they're both raised to some power, then I'm thinking it's probably going to be some sort of u substitution, and I have to figure out maybe what's the best u substitution for this. And for this problem, I'm going to rewrite this as the integral of, see, sine to the 5th x. Isn't that the same as sine squared x times sine squared x times sine x? And then I got cosine squared x dx. So I'm kind of looking at this problem, I'm looking at the exponents, and I'm sort of thinking, now which one might make a good du? And since I see that odd power on sine, I'm thinking I can factor off a sine x. Sometimes I say peel off a sine x, but I guess factor is the correct word there. But I'll peel off that sine x. That's going to be sine x dx. That's going to be the du in this problem. So I'll do, I need a trig identity right here. Sine squared x. Now look, I kind of have two identities for sine squared x. In this case, I'm thinking if sine x dx is du, what will u be? Something with cosine x. I know I have to work in a negative sign in there, but somewhere I got to go with this one for sine squared x. Sine squared x is 1 minus cosine squared x. So this will be the integral of 1 minus cosine squared x times 1 minus cosine squared x. And I like to write whatever's going to be du, or the makings of du, at the back of the problem. I'm just going to do u substitution. Now u substitution, u will be what?
Cosine.
U is cosine x. U will be cosine x. The derivative of u, the derivative of cosine, is negative sine. So there I got to deal with getting in my negative in there. But I'm going to put in the u right here. This is the integral of 1 minus u squared times 1 minus u squared times u squared. Oh, let me go back over here and say negative du is sine x dx. So all of this, there is negative du. I'm going to factor the negative sign out of the problem. I'll put it in the front of the integral sign. And I need to multiply 1 minus u squared times 1 minus u squared, and then distribute the u squared. So 1 minus u squared times 1 minus u squared, that's going to be 1 minus 2u squared plus u to the 4th. Then I got times u squared, and then my du at the back of the problem. We'll distribute u squared. All I did here was FOIL. So I'm going to have negative integral of u squared minus 2u to the 4th plus u to the 6th du. And now we can do the antiderivative. The antiderivative of u squared is, I'm gonna leave my negative kind of in the front there. U squared will be u cubed over 3. How about 2u to the 4th? 2u to the 5th over 5. u to the 6th, u to the 7th over 7. I'll put in plus c, and whether I incorporate that plus c with the minus sign or not, doesn't matter. I'll distribute the negative, and what else do I have to do? Put cosine x back in for u. So negative cosine cubed x over 3. Oh, this will be plus 2/5 cosine to the 5th x. This will be minus cosine to the 7th x over 7, and I'll just leave the c as plus c. There's my answer for this problem.